All right, so now we're talking about the formal definition of a limit. So just reading the definition here, we see that a sequence A of n is said to converge to a number L, provided that for every epsilon greater than or equal to 0, there exists some positive integer, capital N, such that for every little n greater than or equal to capital N, we have that A of n minus L, the absolute value of that is less than epsilon. So what we want to think about here is that as our terms get bigger and bigger, or the indices get bigger and bigger, so as we get further and further out on our list, our terms get really close to this number L. The idea for this epsilon greater than 0, we have that, say you want epsilon to be, say, 0.1. There is some place in our list that all of the terms after that are going to be less than 0.1. And you can pick even smaller numbers for epsilon, and you have to go further down the list to get there, but you will eventually get there. All right, so from my solution to problem 3, you might have guessed that there is this relation between limits of sequences and limits of functions. And we have this theorem here that basically just says if we have a formula for A of n in terms of n, that the limit as n goes to infinity of that sequence is the same thing as the limit as n goes to infinity of that formula. And so this allows us to use all of the rules we know how to do for taking limits to now take limits of sequences also. And so I may just want to remind you of all these limit laws. You can take a minute to look through them. I'm not going to necessarily go through all of them again. All right, so we have the squeeze law that I want to talk about. What this says is we need to have 3 different sequences here. We have x of n, a sub n, and y of n. These are 3 sequences, and we know what happens to the limit as n goes to infinity of x of n and y of n. So the smallest one and the largest one. And so if our a sub n, the sequence that we don't know what happens to it, is in between x of n and y of n for all terms n, and it turns out that the limit as n goes to infinity of x of n is equal to the limit as n goes to infinity of y of n, if that's equal to some number L, then the sequence in the middle, this a sub n, that limit as n goes to infinity also equals this capital L. It's called the squeeze theorem because the idea is if x of n and y of n go to the same thing, this new sequence A of n is sort of squeezed in between, and so that has to actually go to the same thing as well. And another theorem that you kind of get this from the squeeze theorem, but the idea is the limit as goes to infinity of the absolute value of a sub n equals 0. If that's true, then the limit as n goes to infinity actually equals 0.